Jupiter is the largest planet in our solar system, and its secrets are stranger than science fiction. This gas giant could swallow more than 1,300 Earths and still have room to spare. Yet despite its massive size, Jupiter spins faster than any other planet in our solar system.
A single day on Jupiter lasts just under 10 hours from sunrise to sunrise again.
That incredible speed causes the planet to bulge outward at its equator, like a squashed ball.
Jupiter orbits the Sun once every 12 Earth years, moving slowly across our night sky. It sits nearly 484 million miles away from the Sun on average.
Despite that distance, Jupiter is often one of the brightest objects visible from Earth.
Ancient civilizations named it after the king of the Roman gods, for good reason.
Jupiter truly rules the outer solar system, with its overwhelming gravity and immense size. Unlike Earth, Jupiter has no solid surface for a spacecraft or astronaut to land on.
Beneath its colorful clouds lies a thick layer of hydrogen and helium gas.
Deeper inside, the pressure becomes so intense that hydrogen turns into a strange liquid metal. This liquid metallic hydrogen is believed to generate Jupiter's incredibly powerful magnetic field.
That magnetic field is nearly 20,000 times stronger than the one protecting Earth.
Scientists believe Jupiter may have a dense core made of rock and metal at its center.
However, the exact nature of that core remains one of the biggest mysteries in astronomy. Jupiter's atmosphere is a swirling storm of colorful bands stretching across the entire planet. These bands are created by powerful jet streams moving in opposite directions at high speed. The light and dark bands are called zones and belts by planetary scientists.
Winds within these bands can reach speeds of over 350 miles per hour.
That's faster than any hurricane or tornado ever recorded here on planet Earth. The most famous feature on Jupiter is a massive storm called the Great Red Spot. This giant storm is so large that it could fit 2 or 3 Earths inside it.
The Great Red Spot has been raging continuously for at least 150 years. Some astronomers believe the storm has actually existed for over 3 centuries.
Nobody knows exactly why the storm remains so stable for such an incredibly long time. Interestingly, the Great Red Spot has been slowly shrinking in size over recent decades. Scientists are still studying whether this ancient storm might eventually disappear completely someday.
The reddish color likely comes from chemical reactions triggered by sunlight hitting the clouds.
Jupiter's clouds are made mostly of ammonia crystals, giving the planet its distinctive appearance. Beneath those ammonia clouds, scientists suspect there may be layers of water vapor clouds too. This has led researchers to wonder if Jupiter's atmosphere could contain lightning storms like Earth's. In fact, spacecraft have detected massive lightning bolts flashing within Jupiter's turbulent atmosphere. These lightning strikes can be up to 1,000 times more powerful than Earth's lightning. Jupiter isn't just a planet. It's practically a miniature solar system all on its own.
It has an incredible collection of 95 confirmed moons orbiting around it.
Some scientists believe there could be even more moons still waiting to be discovered.
The 4 largest moons are known as the Galilean moons, named after their discoverer.
Galileo Galilei first spotted these 4 moons using his telescope back in 1610. This discovery helped prove that not everything in the universe orbits around planet Earth. The 4 Galilean moons are called Io, Europa, Ganymede, and Callisto, respectively. Io is the most volcanically active world found anywhere in our entire solar system. It has hundreds of active volcanoes, constantly erupting molten rock across its surface. This intense volcanic activity is caused by Jupiter's massive gravity stretching and squeezing the moon.
Europa, on the other hand, is covered entirely in a thick shell of solid ice.
Scientists believe a vast liquid ocean might be hiding beneath that frozen icy surface. This hidden ocean could potentially contain more water than all of Earth's oceans combined. Because of this, many scientists consider Europa one of the best places to search for alien life. NASA is even planning a dedicated mission specifically to study Europa's mysterious ocean. Ganymede is the largest moon in our entire solar system, even bigger than planet Mercury. It's also the only moon known to generate its own magnetic field like a planet.
Callisto is covered in ancient craters, making it one of the oldest surfaces we know of. Its heavily cratered surface hasn't changed much in over 4 billion years of history. Together, these 4 moons make Jupiter feel like its own miniature planetary system. Jupiter also has a faint ring system that most people don't even know exists. Unlike Saturn's icy rings, Jupiter's rings are made mostly of tiny dust particles. These rings are so thin and dark that they're nearly impossible to see from Earth. Scientists believe the dust likely comes from small moons being hit by space debris. Jupiter's incredible gravity plays a surprisingly important role in protecting life here on Earth. Its massive size allows it to pull in or deflect many dangerous incoming comets.
Scientists sometimes call Jupiter the solar system's cosmic vacuum cleaner because of this effect.
Without Jupiter's gravity, far more asteroids and comets might strike our planet directly.
In 1994, astronomers watched a comet crash directly into Jupiter's atmosphere.
That comet, called Shoemaker-Levy 9, broke apart before slamming into the planet.
The impact created massive scars in Jupiter's atmosphere, larger than the size of Earth.
This event gave scientists a rare chance to study a cosmic collision as it happened.
Jupiter's radiation belts are among the most dangerous environments in the entire solar system.
These belts contain radiation levels intense enough to destroy unprotected electronics almost instantly. Any spacecraft visiting Jupiter must be specially shielded to survive this hostile radiation. This extreme radiation makes exploring Jupiter's moons far more challenging than exploring other worlds. NASA has sent several spacecraft to study Jupiter and its many fascinating moons over the years.
The Pioneer and Voyager missions provided our first close-up views of the giant planet.
Later, the Galileo spacecraft orbited Jupiter for 8 years, studying it in incredible detail.
Galileo even dropped a probe directly into Jupiter's crushing atmosphere to gather data. That probe transmitted information for less than an hour before pressure destroyed it completely. More recently, NASA's Juno spacecraft has been orbiting Jupiter since 2016. Juno was specifically designed to peer beneath Jupiter's clouds and study its deep interior. It has captured some of the most stunning and detailed images ever taken of the planet. Juno's instruments have revealed Jupiter's core may be larger and messier than once believed. This discovery has forced scientists to rethink how giant planets actually form in space. Jupiter likely formed very early in our solar system's 4.5 billion year history. And a bit. Some scientists believe it may have even formed before the sun fully ignited. As the first planet to form, Jupiter's gravity helped shape the entire solar system's layout. It may have influenced where other planets, including Earth, ended up settling into orbit.
Some researchers even suggest Jupiter's early movements helped make Earth more habitable for life.
Without Jupiter's influence, our solar system might look completely different than it does today.
Jupiter is classified as a gas giant, but it's often called a failed star by some. If Jupiter had been about 80 times more massive, it might have become a star itself. Instead, it never gained enough mass to trigger nuclear fusion at its dense core.
This means Jupiter shines only because it reflects sunlight, not because it generates its own light. Interestingly, Jupiter does release more heat than it actually receives from the distant sun. Scientists believe this extra heat comes from the planet slowly compressing under its own gravity. Jupiter's overall color pattern is constantly changing due to shifting storms and chemical reactions.
Sometimes, entire bands of color disappear or reappear over the course of several years. Astronomers still don't fully understand why these dramatic color changes happen so unpredictably.
Jupiter's average temperature at the cloud tops hovers around a bone-chilling negation of 160 degrees Fahrenheit.
However, temperatures increase dramatically as you travel deeper into the planet's crushing interior. Near Jupiter's core, temperatures may reach a scorching 50,000 degrees Fahrenheit or more. That's actually hotter than the surface of our own sun in certain regions.
The pressure at Jupiter's core is estimated to be millions of times greater than Earth's.
Such extreme pressure would instantly crush any spacecraft attempting to reach the planet's center. This is why scientists rely on remote sensing instruments instead of physical landers for Jupiter. Jupiter's moon Io experiences such intense tidal forces that its surface constantly reshapes itself. Massive plumes of sulfur and other materials shoot high above Io's volcanic surface regularly. These eruptions create a thin, unstable atmosphere that changes dramatically from day to day.
Io's surface is covered in yellow, orange, and red colors caused by sulfur compounds.
This gives the moon an appearance that some scientists compare to a giant pizza. Europa's icy surface is covered in long, crisscrossing cracks, visible from orbiting spacecraft. These cracks may form as the moon's icy shell shifts above its hidden ocean. Scientists believe hydrothermal vents might exist on Europa's ocean floor, similar to those on Earth. On Earth, Similar vents support entire ecosystems without needing any sunlight at all. This raises exciting possibilities that Europa's ocean could potentially support simple forms of life. Ganymede's magnetic field creates beautiful auroras near its polar regions, much like Earth's. Hubble's Space Telescope images have even captured these glowing auroras in stunning detail. Callisto's ancient, cratered surface makes it a valuable window into the solar system's early history. Because it has changed so little, scientists use it to study impacts from billions of years ago. Jupiter's immense gravity also affects nearby asteroids, capturing thousands of them near its orbit. These captured asteroids are known as Trojan asteroids, and they travel alongside Jupiter's path. Studying these Trojans could reveal important clues about the solar system's earliest building blocks. NASA's Lucy mission is currently traveling to explore several of these fascinating Trojan asteroids. Jupiter continues to be one of the most studied and photographed planets in our sky. Amateur astronomers with simple telescopes can often spot Jupiter's cloud bands from their own backyards. Its 4 largest moons are even visible using a basic pair of binoculars on a clear night. This makes Jupiter one of the most accessible planets for beginner stargazers to observe. Throughout history, Jupiter has appeared in countless myths, stories, and cultural traditions worldwide. Many ancient astronomers tracked its movement to help create early calendars and celestial charts. Today, Jupiter remains a top priority for scientists searching for life beyond planet Earth. Its icy moons are considered some of the most promising locations in our entire solar system. The European Space Agency launched its own mission called JUICE to study these icy moons. JUICE is specifically designed to explore Ganymede, Europa, and Callisto in remarkable detail. NASA's upcoming Europa Clipper mission will fly close to Europa dozens of times. This mission aims to determine whether Europa's hidden ocean could truly support living organisms. Future missions may even attempt to drill through Europa's icy shell to sample the ocean. Such a mission would represent one of the greatest scientific achievements in human history. Jupiter's extreme environment also makes it an important natural laboratory for studying planetary physics. Understanding Jupiter helps scientists learn more about giant planets found around other distant stars.
Thousands of gas giants, called exoplanets, have been discovered orbiting stars far beyond our Sun. Many of these distant worlds share striking similarities with our own giant neighbor, Jupiter. By studying Jupiter closely, astronomers gain valuable insight into how these distant planets might behave. Jupiter's powerful storms and swirling clouds also help scientists understand extreme weather patterns generally. This knowledge can even improve our understanding of complex weather systems here on Earth. Despite decades of exploration, Jupiter still holds countless mysteries waiting to be uncovered. Scientists don't yet fully understand what lies at the very center of the planet. The true composition and structure of Jupiter's deep interior remains a major scientific puzzle. Each new mission brings fresh data that often raises even more unexpected questions. This constant cycle of discovery is exactly what keeps astronomers so fascinated with Jupiter. Jupiter reminds us just how vast and complex our solar system truly is.
A single planet can contain storms, moons, oceans, and mysteries beyond our imagination. It challenges our understanding of what a planet can be and how it can behave. From raging storms to hidden oceans, Jupiter offers an endless source of wonder. Its moons alone could keep scientists busy with research for many centuries to come. Jupiter stands as a powerful reminder of how much we still have left to learn. As technology improves, future missions will reveal even deeper secrets hidden within this giant world. Perhaps one day, we'll finally answer whether life exists beneath Europa's icy shell. Jupiter's story is far from finished, with new chapters being written every single year. Each image and data point brings humanity closer to understanding our cosmic neighborhood. The truth about Jupiter is more incredible than any myth or legend ever imagined. And as we continue exploring, this giant planet will keep shocking us for generations to come.